Hi and welcome to nth term of a quadratic sequence, part 2 with Mrs. Kirby. I've done the second part of this video because I wanted to do a quadratic sequence which had slightly bigger numbers. So I'm just going to go through the same process again, which is working out the difference between each term. So how I get from 11 to 22, I add 11. To get from 22 to 39, I add 17. To get from 39 to 62, I add 23, and to get from 62 to 91, I add 29. And remember, that is my first difference. That is not constant, so that means that I then need to look at the second difference, which is the difference between this sequence of numbers here. So the difference between, or how do I get to 17 from 11 is by adding 6. How do I get from 17 to 23? I add 6. And how do I get from 23 to 29? I also add 6. This is the second difference, and because the second difference is constant, it means that we've got a quadratic sequence, which means it's got n squared in the rule. I take the second difference, which is constant, I halve it, that gives me 3, and that tells me what the number in front of the n squared is. So in this case we are going to have 3n squared, and I'm going to highlight that using my orange so I keep the colours as the previous video. Okay, right, then we draw out a table, and the table has n, the position of the term in the sequence, our 3n squared, our original sequence, and a new sequence as a result of this table. I like to just have these two lines because n is 1, 2, 3, and 4. You don't have to use all of the terms that you've been given originally. Then I'm going to do 3 lots of n squared. So 1 squared is 1, 3 times 1 is 3. 2 squared is 4, 3 times 4 is 12. 3 squared is 9, 3 times 9 is 27. And 4 squared is 16, 3 times 16 is 48. My original sequence, you can still see it there at the top, 11, 22, 39 and 62. My new sequence is going to be formed when I find out how I get from my 3n squared to my original sequence. And in this case, I need to add 8. I'm not going to put an add sign in, I'm just going to leave it as a positive number. To get from 12 to 22, I add 10. To get from 27 to 39, I add 12. And to get from 48 to 62, I add 14. My new sequence, I'm now going to determine the linear rule for this sequence. So write the numbers out again, 8, 10, 12 and 14. The difference between each term is plus 2, plus 2, plus 2. That plus 2 tells us that 2n is part of the rule for that sequence. And remember that we write the 2n bit first before we go and find out what the number bit is at the end. To find the number bit, we reverse our rule. So instead of adding 2, we take 2 away. 8 take away 2 would take us to 6, which is still positive. So the whole bit of the linear sequence would be 2n plus 6. Highlight that with my purple pen. And then I'm going to put the two highlighted sections together, and that will give us the whole rule for our quadratic sequence. So finally the answer is 3n squared plus 2n plus 6. Hope that helps.